get started, I will firstly briefly introduce myself first. Hello everyone, my name is Fiona and I'm the Content and Social Media Coordinator here at PXChange. Welcome to our webinar on Customer Churn Prediction, where we show you how predicting customer churn with machine learning is made possible and easy with the no-code AI and analytics engine. Thank you so much for taking time out of your busy schedule to join us today. We promise you it will be worth your time. Let me first introduce our company to you. PXChange is a deep tech company that focuses on the mission of democratizing data science and AI to everyone. We strongly believe that the pathway to AI can be simplified, streamlined, and also can be cost-effective. Our flagship product, the AI Analytics Engine, is a no-code, end-to-end machine learning platform. With the engine, you have machine learning at your fingertips without having to write a single line of code. This is particularly helpful for users who may not have the technical expertise or any coding knowledge, but still want to leverage machine learning. For today's session, I am joined by one of our expert data scientists, Ray, and he will take you through how to predict customer churn step by step using a new feature in the AI Analytics Engine, which is Explainable AI. We will start the webinar with some introduction, followed by the customer churn prediction use case demonstration, and we will also have a Q&A session at the end. So if at any point of the time you have any question for us, feel free to pop your questions in the chat box or in the Q&A section. Now, if you are wondering, what is the AI Analytics Engine? Well, the engine is a complete end-to-end machine learning tool that takes you from preparation of an analysis of raw data all the way to model deployment in minutes without any coding necessary. It streamlines the traditional end-to-end machine learning process and empowers anyone, even non-technical users from any industry, to create and deploy their own machine learning models to get predictions from. Before we jump in further, we would like to get to know all of you better. So we are just going to take the next 2 minutes to ask you a couple of questions. So we really appreciate it if you could participate by answering the poll questions. The first question I have is, which industry are you from? Seems like we have people from everywhere. We got 33% from telco, and then another 33% from hospitality and from other industry as well. In case any of you are unfamiliar with the term customer churn, it is essentially defined as the propensity of customers to stop doing business with the company in a given time period. It has become such a significant problem and is one of the biggest challenges that many companies worldwide are facing. This is because customer churn introduces not only loss in income, but also other negative effects within the operations of the companies. In many industries such as telecom and banking, customer churn prediction plays an important role in business success due to the fact that the cost of attracting new customers is much more than retaining existing ones. Now I'll be moving on to the second question. How much do you think a company's profit can increase with just a 5% increase in customer retention? I can see that most of you, and in fact, all of you think that a 5% increase in customer retention can lead to 10% profit. However, a 5% increase in customer retention can increase a company's profit by as much as 95%. Also, it can cost between 6 to 7 times more to get a new customer as compared to retaining an existing one. Since losing existing clients can be hugely damaging to most businesses, customer churn prediction and prevention becomes a crucial part of any sustainable business growth. And that is made easy and possible if you leverage machine learning into your customer churn prediction journey. Now let us move to the last question, which is, how do you think machine learning can be used in churn prediction? Perfect. Let me just share the results. And all of you have got it right. The answer is actually all of the above. Utilizing machine learning for customer churn predictions open up plenty of opportunities for many businesses and industries. This is because machine learning is able to analyze client behavior based on their demographics, psychographics, transaction data, and etc. to measure their probability of churning precisely and accurately. For example, by using the data on customer behavior, a customer churn prediction model can be used to understand the likelihood and evaluate how likely it is for each customer to leave the product or service. Although there is no single action that can be taken in preventing customer churn once they've been identified, it can often be as simple as reaching out with targeted communication or offer a discount or offer of some kind. Organizations can also choose to create targeted marketing campaigns to encourage clients who are most at risk of leaving to continue using the product or service. All right, let's now get straight into the data set that we will be using for today's demonstration. We will be using a publicly available data set from IBM that was published on Kaggle of a telecom company that plans to focus on customer retention programs. We will use the data set to analyze all relevant data to predict their customer churn. For those of you who are just joining us, welcome to the webinar. We are just about to start the demonstration in a bit. If you have any questions or if you have a specific use case you would like some help with, feel free to contact us or book a demo with our team. You can find all the links on the chat box. For now, Ray will begin his demonstration. We will also reserve a couple of minutes at the end of the webinar for a Q&A session. So again, if you have any questions, we will be happy to answer them at the end of the demo. For now, I'll pass on the time to Ray.
Thanks, Fiona. So before jumping to the engine, let's quickly look at the main steps involved for predicting customer churn here. So first, we need to import data into the engine, and then we need to clean and prepare the data into the format that generally machine learning models accept. And we can further specify the target column, which we want to predict, and also select the features that are likely to have the predictive power based on domain knowledge. And once these steps done, we can proceed with training a selected models. And once we are happy about the performance of a model after evaluation, we can deploy and use it to serve prediction requests. And in addition, using a model with accurate prediction as a black box is often not enough. And we want to not only predict which customers tend to churn in this case, but also understand why they churn, which would be very helpful for prioritizing our strategies. So this is where explainable AI comes into play. So explainable AI basically is a set of tools to help interpret machine learning models. It makes model outputs easy to understand, which gives us a lot of confidence when using a model for prediction and further decision making. So in the engine, we use mainly 3 sections to help users understand models: feature importance, prediction explanation, and what if tool. And we'll talk about the details while going through the engine later. So now let's see how the engine can help handle the task of customer churn step by step. So on the project homepage, we start with adding new data set. Here, different data sources are available, such as uploading a file or connecting to a database. And we're actually open to add new sources upon user's request. And so here is an imported data set. From the preview, we can see each row represents the status of a customer. And columns here basically include some basic customer information and also the target that indicates whether a customer churns or not. So we can also check the analysis tab for some statistics and visualization for each column. For example, here the columns like these three, count, country, and state, can be removed as only a single value is included, which means these columns are not predictive in determining whether a customer churns. And to clean the data set, we can create a data wrangling recipe. So let's skip the process here and directly jump to a prepared recipe. We can immediately see the suggestion of dropping these columns is already there, together with an explanation why it's suggested to drop these columns. And so we can simply add it to the action queue, and the preview of the data is already updated as if the action is applied. So basically here an action refers to a step that processes the data. And here we support a comprehensive list of actions to let users to flexibly prepare their data. And once the recipe is finalized, we can commit the actions. Basically, this one, for example, is a finalized recipe. So the actions basically here cannot be modified and actually are saved in order. So we can use this recipe to process new data available with the same schema automatically, without repeating the process of adding and removing the steps in data preparation. So once the recipe is finalized, in the meanwhile, the cleaned data set is automatically created. So from the analysis again, we can basically see the distribution of the target column, which is churn label. This basically indicates the churning customers take a very small proportion than those who won't churn. So to start the task of predicting customer churn, we basically need to create an app first. Then we need to here select predict a column, which is churn label. And then confirm this is binary classification. So when this process finishes, like this one here, we can see basically a list of recommended features automatically created. So if we check in the selected features here, we can see some columns are not generally useful, basically are removed from the list. For example, the customer ID. And based on the selected columns, we can start to train a new model. First, before the model training, we first need to select which algorithm to use. So rather than training all these supported models and picking up the best one, here the engine offers an estimation of the performance for each model. For example, the performance is estimated as 77%. And we also have the estimation together with the performance. We offer the estimated time in training and prediction. So with this feature, we can basically compare different models before training any of them. So for example, here, we can see both light GPM and random forest are estimated to have the same performance. But for light GPM, it actually takes less time in training, but more time in prediction. So with this feature, this actually saves lots of time in and also computational resources, in contrast with training all the models and pick up the ideal one. So once the models are trained, we have an overview of the evaluated results through model leaderboard. Here, model performance is represented by prediction quality. So the best models indicated according to different criteria. For example, we can quickly find gradient boosting is the best one in terms of the performance and the prediction time. And also decision tree model has the shortest training time. And we can also check more details and when clicking on the model. So here is a trained light GBM. We can simply follow up the storyline here to review how the model is trained, starting with first the data set and the task type of which it indicates its binary classification, and basically it's used to classify whether a customer churns, and also the selected features to train the model, and the algorithm. And then under the insights, basically we can check the accuracy of model prediction indicated by performance here, and also these three paths that help understand the model. As we mentioned earlier, we'll come back to this in a minute, but let's first check the performance. So we can see a very thorough list of evaluation metrics on the left panel, and also the supported visualizations on the right. So suppose this is our first iteration. We can use this model as the baseline, given the area under the precision recall curve basically is above 65%. But as mentioned earlier, it's safer to use a model that we understand. So here we can further check the feature importance. This basically indicates how much each feature involved impacts the model prediction on average. So for example, the tenure basically has the largest effect overall, followed by contract type. And to see the feature contributions for each individual customer, we can check further the prediction explanation. So here the table on the left gives a list of examples sampled from the input data set. And here the probability score is basically the predicted result from the model indicating how likely a customer churns. So once we select a customer, we can see more details of how the model prediction basically is made on the right. So for this example, right, the customer is predicted to churn, and as the likelihood or probability score here is above 0.5. So how does the probability score is achieved? The answer basically sits on the bottom right here. So the effects of different features basically listed with the degree in descending order. So here, starting with the baseline, which means the average probability is about 0.4, then short tenure, which is only a month in this example, basically increases the churning risk by 0.24, and monthly contract basically increases this probability by another 0.05, and so on. So from this explanation, we can get some insights on how to retain this customer who actually is likely to churn. For the insights part, we can basically look at a different example and start with a customer of churning probability around a median level. For example, around a 0.5 first. If the probability is too high, as this example, then it will be very challenging. And we can come back to these customers at a later stage. So if the probability score is too low, then the customer is less likely to churn. And indeed, no action is actually needed. So we can look at some low-hanging fruits first. For example, this one, the customer is predicted to churn, but only with a probability 0.5. So basically, we can see the top 3 features that increase the churning risk of this customer are contract, internet service, and payment method. So next, we can try if changing any of these feature values can help reduce the probability. So here we can simply copy this example to what if. And yeah, while waiting up the instance to warm up, we can first talk about what if tool here. So what if basically is also called counterfactual explanation. It's used normally to generate the prediction of the model by giving an input example. So basically that's the features used to train the model. And this actually applies to any example that even hypothetical and does not exist or included in the data set. So yeah, so basically it takes a little bit more time to warm up the instance. So basically, as we just saw from the prediction explanation, we can check if changing, potentially the contract, payment method, and also the internet service can help reduce the chance of churning. So yeah, it's ready now. We can first try predict. And yeah, So the predicted probability should be the same as we saw earlier in prediction explanation, as we haven't changed any of the feature in this copied example. So now we can see if a different contract type can help prevent this customer from churning. Let's basically select 1 year and predict. Yeah, so the result here shows a 1 year contract, as we only changed, this feature, right? So the 1 year contract actually reduces the chance of churning for this customer to about 0.33, which is pretty effective, as the customer would be less likely to churn now. And we can add this to comparison. So if we look at this comparison panel, here we've also added another 2 examples. So the first column basically is the original example that the customer has a 51% chance to churn. Then it's reduced to 33 by changing the contract from monthly to 1 year. And the third column basically suggests changing the payment method from electronic check to bank transfer. Basically, also makes the customer less likely to churn, as it's only 42%. And the same for the last column, which actually is switching the internet service from fiber optic to DSL. So as indicated above, we can basically see all three changes. These 3 can prevent the customer from churning. So once we are okay with the performance of a model, which also makes sense to us now, we can then deploy the model and use it for prediction. So after the model is deployed, we can basically upload some files to make predictions. And here is an example. So basically, the predicted results include first probabilities for which we can see the column corresponding to yes in probabilities actually indicate the chance of the customer churning, and also a column indicates whether the customer churns or not, also together attached to our original customer information submitted for prediction. And we can also link the deployed model to a dashboard, for example, for all the customers we want to predict. We can see a percentage of customers who are likely to churn. And we can also check the information and the predicted churn label together for each customer. And as well as the probability that the customer churns. So this is pretty much an end-to-end demonstration of using the engine to predict customer churn. Thank you very much. And back to you, Fiona.
Thank you, Ray. Somebody has just asked a question, and it says, how do you select the trading features?
How do we normally select the features, right? So that basically depends on our domain knowledge, basically on what kind of features are actually likely to be predictive to, to estimate whether the customer will churn or not. And some features basically are not that straightforward to get. In this case, we used a simple example, but normally, some features can be achieved by, aggregation over, a certain period of time. The practical procedure basically is, based on our domain knowledge, we select or generate a pool of, potentially useful features from our data, and then, gradually to improve the performance of the model.
Great, thank you, Ray. Hopefully that answers your question. Does anyone else have any question? I'm just going to give some time for you all to type your question in the chat box. But don't worry if you come up with any questions later on. You can always just reach out to us via the links that I've sent in the chat box, and we'll get back to you for sure. All right, seems like there's no other questions from the audience. If that's the case, thank you, Ray, for taking us through the demo and for showing us how to predict and prevent customer churn using the engine. So just to summarize, we've discussed the importance of customer churn prediction for businesses, and you've also seen how you can build your own predictive model to start predicting customer churn accurately. All this is done on the AI and analytics engine with zero coding necessary. By using the engine, you can make quick decisions and instead focus more on the business side. This includes implementing solutions to eliminate the problem-causing churns using our new feature, Explainable AI, without needing any machine learning expertise or coding knowledge. It's time for you to start reaping the benefits of machine learning to predict and prevent customer churn. And with that, we've come to the end of our webinar session. Thank you very much to everyone for joining us today, and we hope you've gotten something valuable out of this event and that you are ready to start your journey on using machine learning to identify the likelihood of your customer churn. Let's continue this conversation on our Slack community. We are happy to answer any and all of your questions. Also, if you have a use case in mind that you will need help with, simply book a free demo with us. Alternatively, if you're ready to try the engine for yourself, we have a 2-week free trial just for you. You can find all these links on the chat box below. Thank you, everyone. I hope you have an amazing rest of the week.